The question of when, or even if, the world will end has captured human imagination for millennia. Myths, prophecies, and science fiction have all grappled with the fate of our planet. But in recent years, scientific advances have allowed researchers to develop increasingly sophisticated models using cutting-edge technology and vast amounts of data in an attempt to forecast the future of life on Earth. While the end of the world remains a complex and uncertain topic, new studies have shed light on just how and when our planet might become inhospitable to life as we know it. One of the most significant breakthroughs comes from a team of scientists who, in May 2025, published the results of an ambitious study that aimed to predict the distant future of Earth's biosphere. Utilizing NASA's planetary modeling software, the researchers ran an astonishing 400,000 simulations, each exploring possible outcomes for our planet over the next several billion years. Their results point to a sobering conclusion. In about 1 billion years, Earth's atmosphere will lose its vital oxygen, making it impossible for aerobic organisms, including plants, animals, and humans, to survive. The driving force behind this prediction is the changing nature of our sun. Over time, the sun is gradually increasing in brightness and heat. This process, though almost imperceptible over a human lifetime, has profound implications for our planet's climate and atmosphere on a cosmic timescale. As the sun's output intensifies, Earth's surface temperature will rise, accelerating weathering processes that draw down carbon dioxide from the atmosphere. With less carbon dioxide, plants, Earth's great oxygen producers, will struggle to survive. Eventually, photosynthesis will falter, and oxygen levels will plummet. The simulations suggest that, around 1 billion years from now, this cascade of changes will reach a tipping point, triggering the collapse of the biosphere as we know it. This finding is striking not just for its specificity, but also for the vast timescale it contemplates. For context, 1 billion years is far longer than the entire span of complex life on Earth so far. Yet, for all its magnitude, this natural process is not the only threat facing our world. In fact, more immediate dangers, driven by human activity, have become the focus of urgent scientific and political concern. In January 2025, the Bulletin of the Atomic Scientists made a dramatic statement about the state of global risk by moving the doomsday clock to 89 seconds before midnight. This symbolic clock has, since 1947, served as a measure of how close humanity is to self-inflicted catastrophe. Its setting is determined by leading scientists and security experts who consider factors such as nuclear proliferation, climate change, disruptive technologies, and geopolitical instability. The 2025 adjustment is the closest the clock has ever been to midnight, reflecting a period of unprecedented danger. What motivated this alarming move? Several converging crises. Nuclear tensions are once again on the rise, with nations modernizing their arsenals and international treaties under strain. The spectre of nuclear war, which once seemed to recede after the Cold War, has returned to haunt policymakers and the public alike. In parallel, artificial intelligence, once the subject of speculative fiction, has made rapid advances. While AI offers enormous potential for progress, it also carries risks if misused or left unchecked. A 2024 survey of experts estimated a 15% probability that AI could cause human extinction within the next 30 years, a statistic that underscores the seriousness of the threat. These human-driven dangers are not limited to nuclear and AI risks. Climate change, biodiversity loss, and emerging pandemics all add layers of complexity to the global risk landscape. Each of these challenges is interconnected, and their combined effects could potentially destabilize societies or disrupt the natural systems that support life. Scientists emphasize that these perils are not inevitable. With foresight, cooperation, and innovation, humanity can work to mitigate them. Yet the doomsday clock's latest setting is a stark reminder that the window for action is narrowing. Looking further ahead, the natural evolution of the planet and its environment remains the ultimate determinant of Earth's habitability, even if humanity overcomes the immediate existential threats of this century. The inexorable march of time will, eventually, render Earth uninhabitable. The billion-year countdown to atmospheric oxygen loss is driven by processes beyond human control, governed by the life cycle of our star. But before then, other cosmic events may intervene. Asteroid impacts, supervolcanic eruptions, or nearby supernovae, all of which have shaped Earth's history in the past and could do so again. For now, however, the most pressing dangers stem from our own decisions. The lessons of the doomsday clock and the warnings from scientists are clear. The fate of humanity, at least in the foreseeable future, is in our hands. International cooperation to prevent nuclear conflict, the responsible development and regulation of AI, and urgent action to address climate change are all essential steps. While the distant future may be shaped by the cosmos, the near future depends on the choices we make today. It is important to recognize that scientific predictions are always subject to revision as new data and understanding emerge. The billion-year estimate for the end of Earth's oxygen-rich atmosphere is based on our best models, but those models will evolve as we learn more about planetary science and the dynamics of our sun. Similarly, the risks associated with nuclear weapons, AI, and other technologies are informed by current trajectories, but proactive policy and innovation can alter those paths for the better. In summary, the search for the exact date of the end of the world is a blend of scientific inquiry and philosophical reflection. Recent studies provide a clearer picture of Earth's ultimate fate and the timescales involved. On the scale of geological epochs, life on Earth has about 1 billion years before the atmosphere shifts beyond what current forms can endure. On the human scale, the greatest threats may emerge within our own lifetimes, driven by the very technologies and systems we have created. The future is not set in stone, and while some cosmic events are beyond our control, many of the most immediate risks are not. Our challenge is to heed these warnings, to act wisely, and to secure a future for generations yet to come.